Hey guys, and welcome to my channel. Let's do an interesting test today on this my second day. There is the first one, and here is the second one. That one is parallel. So, well, let me tell you what kind of test I'm going to do. So, here I have 16 panels and 16 panels. They are currently on different trackers, right? What if I put these same 16 panels? I mean, they are equal. They are on all cases they are along the 435 watts. Numbers are equal, just like the place where they are mounted are different. So here is the eastern slope with the 35 degrees angle, and this is the southern one with 10 degrees angle. What if I put them in parallel, and whether I will lose or gain anything in production? So let's check. This is right now, currently they are working on the two different MPPTs. The first one is the eastern one, the second one is the southern one. Let me quickly show you. It will take just a second. Hold on, because I just like yesterday finished the setting up of the additional the second array of 16 panels. So if you remember well, there it used to be my off-grid garage system, but it is currently not the off-grid garage. It's currently moved to my day. Yeah. So let me show you quickly. Yeah, that's the array. It now currently has 16 panels, not 11 as it used to. 16 panels, and they are currently on PV2. And let me show you how does the other array look like. You probably remember it from one of the previous videos. It's this place where it is located. So exactly these 16 panels located on two slopes, presumably same angle, but like 35 degrees is the tilt, unlike 10 degrees on that piece. So let's go and check and do the test. I'm really curious what the results will be. I don't know yet. So let's do the test together and we will see everything. All right. So again, eastern, southern, 35, 10. Number of panels equal. Panels are absolutely identical. The only thing that is different is that this one has got 6 optimizers. So out of 16 panels, only 6 of them has got optimizers, and the other 10 don't. And here, no optimizers are being used at all. So remember the voltage, remember the power, and the total power is 177, 176, 77, whatever. Regardless, we are doing this live, so you will not lose anything, I hope, because I'm switching off PV right now, and I'm literally removing it with you, so you're able to see everything yourself, and I'm not adjusting anything, changing anything, etc., etc. Give me a second. Okay. We are also doing it live. Specifically live because, well, it is the most interesting part to have it done exactly at the same sequence. So, as you may see, both of them are right now on PV1, and like input 1 and input 2, that's it. Let's see what the difference is. Let me remind you that the inverter has got the global MPPT scanning algorithm. And let's see if there will be any difference, if any. I would say there is some, but if it's much, I would not be so confident to say there is a lot of difference. Right? Well, very less than 10%, 5 to 7, maybe. And one more thing. So I was told by one guy that I should be aware and to not do this really for the full time, so to say, Because if you remember, there are like two fields, two arrays, and one of them is definitely a little bit weaker and the other one is a little bit stronger. So he says that you should do some kind of diode blocking path, probably. But remember, I have optimizers here on this one, and I don't have any optimizers on this one. So let's check if there will be any current flowing. I have this measuring device, I will give you the link to it. If there is any current flowing once the DCs are off. Right now, as you may see clearly, it's minus 2.8 amps, right? Because like, if I will do this here, it will be showing you this plus, right? Okay. And on this one, we have like this, but they are working. But let's check what is going on to happen if I switch it off. So yeah, PV is switched off right now. Let's do the same thing. If the bigger field will supply some kind of current to the smaller one, and you may see that 0.8 amps is actually going somewhere. Question where? Remember, this one on red was with minus and now it's in plus. This means that the smaller, weaker array actually is receiving some current. So right now, the more loaded array is actually pulling, not pulling, but pushing some power, not much, just like 0.8 amps. But I mean, that's in the numbers of the open circuit voltage. I don't know, where do I measure it? Let's check. I mean, we can do this, of course, for sure, but I just have to reconnect this stuff to do this properly. And we have a place where we can measure it all. And this place is right here on my temporary measuring device. It will be probably out of range because this one, yes, it's out of limit. It's over 600 volts because the limit for this one is 600 volts. So you can imagine, let's say even it's 600 volts. Just guess, just calculate 600 volts per like little bit less than 1 amp. It's 600 watts. It's a lot. It's quite a lot, a hell lot of a power that is getting pumped from one array to another, from this one to this one. This means that this set of panels will be degrading faster. So once you are paralleling, do not forget to use any kind of diode blockage. That would really help your panels to survive and to live longer. This is very, very important. For now, I'm switching it on. While it's on, it will be working nicely. It will not be pumping any power to anywhere. But literally 600 watts is quite a lot. So consider this and think of this and do something that will prevent this thing from happening while stuff is off. When can this happen? For example, once you're off grid and once your batteries are charged, and if you don't have any possibility to sell back to the grid, this might be the case. Still, if you are even selling this to the grid, it will be a little bit better if there will be any kind of a blockage on this kind of array, and probably putting an optimizer, at least one, on this array will definitely help. But I mean, I'm stuck with my optimizers. They haven't arrived yet, and that's the trouble that I have. So consider this and think about this fully. You have seen two important things and factors to consider. Thanks for now, and see you later. Bye.